Hi, thanks for joining us today. In this video, we're going to be finishing off lesson 6-4 by discovering the formula for the average value of a function. Average value is something that comes up very frequently on the FRQs, so please come back to this video if you ever get confused. Go ahead and do these 3 questions if you want to try them out. If you get stuck, watch a little bit more of the video. I'm going to do it all in one shot. Did you try it out? Pause the video. 3, 2, 1. So we're going to draw a horizontal segment that represents the average y value of that piece of the function. So in case you have trouble visualizing it, we're talking about, I don't know why it looks so choppy. We're talking about, this is the function I'm interested in. And we want to know, where is the average y value in that interval? So I'll draw my trusty horizontal line segment. And I'm going to slide it up until where I think now the average value is. Now, the average value can't be down here. For a function, for any kind of average, if I averaged a bunch of negative y values, if I averaged a bunch of, positive y values, I couldn't possibly get my average to be a negative y value. Likewise, I couldn't really get a value that's outside of the range of y values I got. That my y value, my average, has to fall somewhere within the range. Somewhere within the range between the lowest and the highest y value I counted. Just like when we're averaging finite amount of things. Likewise, it couldn't be above. It doesn't have to touch the function, which is a common student response. What it must do is it must touch the function if the function is continuous. But it only has to ever fall between. So we'll say our average value is about there. Okay? Now they want me to find the area of the rectangle formed. And just to be clear, we're talking about this area right here. Sorry, this rectangle. So that rectangle, our height is my average height. The width of that rectangle is just the change in the x values, which is b minus a. So far, so good. Now, in this next line, what happened was I replaced a with this definite integral, which again represents the signed area between a and b, between the function f of x and the x-axis. So let me shade in what that represents. Because why should these two be equal? Well, the basic idea here is that if all this blue was, let's say, sand or even water, would it fit into my green bucket? If it was sand, we would push all this over here, and we would say this probably fits right there in that empty gap. And that more or less would be a definition of the average value. Is that we want to make sure my average value was such that the area of the box was equal to the area between the curve, the signed area between the curve. And that's what allows us to solve for the average height. My average height, this guy, my average y value, my average f of x value, however you want to think of it, we would just divide both sides by b minus a, and we would get this integral divided by the change in the x direction. So, again, how do you get an average by hand for a bunch of test scores? You would add up all your test scores and then divide by the total number. So again, that's another use of the integral of adding up. This says add up all these y values and we'll divide by the change in the x, the number of x values. So that's another way to understand what happened here. So here's it written up nicely. This is our big formula. The average value, the average y value, is the area of the region divided by the width of the region. And that's how I get the average y value. The only reason students tend to mess this part of it up is there's another average we use in calculus. Pause the video if you want to think about it. It's the average rate of change, which is AROC. And there's multiple reasons. It's not just the word average. It's that AROC of f of x on a to b. AROC also has the same denominator. So be very careful. For most questions, it's clear. Most questions, it's clearly asking you to find the average rate of change versus the average value. Average rate of change is this. Average value is this. That's 90% of the questions. I will try to say this, though. There will be certain questions, which we will get to in May, to review, where your function f will be a rate function. Like if my function was a rate of rainfall, going back to 6.1, and I wanted to find the average rate of rainfall, that would be an average y value. So I'd be using this. If they ask me to find the average rate of change of the rainfall, we're talking about this. So just make sure you pay attention to what the y value represents. If they're asking me for an average y value, I'm using this. Whatever the y represents. If they ask me the average value of that, the average y, I'm using that top. If they ask me for average rate of change of whatever the y value is, we're using this bottom formula. So just keep that straight as we go on. One quick example. This is pretty easy. It's just a formula. So here's my function. They want me to find the average value without using a calculator. Well, I'm going to take the integral. I'll say the average value would be the integral from 0 to 2, a to b, of f of x all over 2 minus 0. Make sure you keep the denominator. Write that first if it helps you. On the top, we're going to anti-differentiate x to the 4th over 4 minus x squared over 2. Evaluated from 0 to 2. Plugging in the 2 first. I'm so sorry. It's really being feisty today. 2 to the 4th over 4. 2 squared over 2 minus, please, for the love of all that's good and holy in the world, use parentheses when you subtract. Once you get really good and careful, you could write that as 0, but again, some people are messing that up. And that would be a totally acceptable average value. Now, if you look at example 5, for those of you with the book, example 5 is going to ask us to use this value, so I am going to simplify. That's 16 fourths minus 4 halves minus 0. 4 minus 2 over 2, 2 over 2, or just 1. So it says my average y value for this part of the curve is 1. Now, that's a little misleading. It might look a little low to you since so much is up here, but keep in mind that we're counting these as negatives. So if I'm talking about the area, here, I'm talking about this being a positive represented area. Sorry. And this would be the negative area. I don't know what color I want to use. And I want it all to fit, so I need a tinier pen. So we're counting that. So would all of this fit into my bucket? Yes, because we get to use that as negative. So if we're trying to dump all of this blue into the green bucket, the blue could fill in that orange bit and then all that. So it would be an accurate y value, an accurate average value. Now, this next question has been confusing people, and frequently on tests, people are getting it wrong. So it says, use a calculator to find the average value of C, to find the value of C, to find the value of C. That's an X value in the interval where f of C equals the average value. Well, the average value found in example 4 is 1. So they want you to find C that makes this equation true. I'm not sure why, but people seem to lose their minds on this question. They're asking me to solve this equation. This equation is pretty much the same as this equation because f doesn't care which letter is inside of it. Can you solve this equation? To solve this equation, you would just do x cubed minus x, that's what f of x is, equals 1. To solve this equation, you would just do c cubed minus c equals 1. I would liken this in class to saying like f of cloud equals 1. Well, that would just be cloud cubed minus cloud equals 1. That one looks more like a broccoli or something. It doesn't matter what's inside f. You need to know how to solve a function equation like this. If they're saying what value of x would make this true, you need to know to replace it and then solve. You don't need to know how to solve this by hand, it's with the calculator, but it doesn't really matter if we call it x or c or cloud. To solve this with the calculator, graph that as y1, graph that as y2, and intersections, right? So as you can see, that's all I've had done. I'm going to zoom 6 to make sure we're all looking at the same window. It's going to take forever because the computer's processor is recording and graphing, which I guess is too much. Hooray! Second, intersect. Second trace, number 5, intersections. Scroll, scroll, scroll. Enter, enter, enter. And my intersection is x equals 1.325. You won't lose any points if you write x equals 1.325. 1.324 would also be acceptable for truncators. But again, what the AP people would really like you to be able to do is, hey, they ask you to find the value of C, just call it C. Make the AP people happy. That's your only mission in life, especially on May, especially on the AP test in May. That's all there is to it. You should try the rest of assignment 6-4, especially problems 8 through 14, especially problem 14. 14 is a lot like this one. If you get stuck on 14, I don't know. Come back and watch this, but you've already watched it, so I don't know. Watch this video. Try problem 14. Good luck. Have fun. I'll talk to you later. Bye for now.